All right, whenever you're ready, Will.
Okay, so my topic is premium sportsman's ammunition and uneconomic purchase. And for this study, I will be focusing on hunting ammunition for deer hunting. So the purpose and goal of my project was to determine whether or not sportsman's ammunition categorized as premium ammunition performed well enough to justify its exorbitant cost. For the sake of this study, I'm defining premium ammunition as hunting ammunition that costs over $35 for a box of 20 rounds of one common caliber, the .30-6 caliber. This is in contrast to cheaper ammunition options that can cost less than $20 for the same quantity of rounds. In this study, I was seeking to discover whether or not expensive ammunition granted its user an advantage in the field equal to its large price difference. At the conclusion of my study, I found that it did not, and that sportsmen would be wise to save money by purchasing cheaper ammunition. My project is significant because the conclusion that I reached in this study will enable sportsmen to make a more informed and economic decision. So that brings me to my methods. I approached this question by conducting 2 experiments, one testing the accuracy and one testing the terminal ballistics of premium ammunition. And also I tested 2 other samples of ammunition of a lower price category in order to provide a comparison and to hopefully help deduce what kind of correlation there could be between an ammunition's price and its performance. I felt the need to conduct my own experiments in order to provide unbiased and accurate data that would be applicable to my study. Because the only other people to conduct experiments of this manner are the ammunition manufacturers themselves, such as Hornady and Federal Premium, who obviously have a potential bias in favor of their own ammunition, and review authors such as Gerald Almy and Bryson Townsley, who write for magazines such as Sports Field and Field and Stream. These review authors do not regularly consider the price of ammunition in their articles, so I felt the need to conduct my own experiments to make it more applicable to my study. In my first experiment, the accuracy test, I tested all 3 samples at both 50 yards and 100 yards. Even though I would have preferred to do as many trials as possible, the resources available to me limited my project to just 1 trial at each distance. The experiment was done in an indoor range that was climate controlled in order to prevent any unexpected variables such as wind deflection or fluctuations in temperature. I took as many precautions as possible to ensure that there was few sources of error during the experiment. For example, I allowed the barrel of the rifle to cool for approximately 10 minutes in between each trial. The planning for my second experiment, the terminal ballistics test, was a little more complicated. In order to conduct my terminal ballistics experiment, I had to find a substitute for ballistic gelatin, which is the medium used by most professionals when conducting terminal ballistics tests. Ballistic gelatin can be quite expensive, and the resources available to me did not make its use feasible. I settled on using a saturated phone books as a medium, which is used by many amateurs who wish to test their own ammunition. All 3 samples of ammunition were fired into saturated phone books from approximately 10 feet away. In the terminal ballistics experiment, I was looking for max retention, penetration depth, and bullet expansion as an assessment of the bullet's performance. That brings me to the results of both of my experiments. This is the results of the accuracy test. I want to explain a little bit more how I came to these results. I measured the accuracy of each trial by firing 3 rounds in each trial, and the area of the triangle created by these 3 rounds is defined as the grouping of the trial. The smaller the grouping, the more accurate the trial was. So as you can see, at 50 yards, the low price sample actually performed the best. Its grouping was so small I found it immeasurable. However, at 100 yards, the low price sample and mid price sample's accuracy began to deteriorate. The high price sample clearly performed the best at 100 yards, keeping its grouping within 0.1 of a squared inch. This is because the low price sample's bullet has a round-nosed tip made of lead and a blunter ogive. The ogive is a term used to describe the sharpness of a projectile's tip. It can be concluded from this experiment that at 50 yards, air resistance did not have a major effect on the accuracy of any of the bullets. However, at 100 yards, the low price sample's performance began to deteriorate. Despite this, the results of the accuracy test can still be said to be in favor of the low price sample. Because even though the low-priced ammunition did not perform as well as the high-priced ammunition, it did keep its grouping within a square inch, and the accuracy of that level is still extremely lethal and adequate for the common deer hunter. The purpose of this experiment was to discover whether or not the difference between accuracy would be great enough to justify the large price difference. The low-priced ammunition sample performed excellent considering its price of less than $20, while the high-priced sample performed about as much as I would expect it to for its high price of over $40. That brings me to the results of my terminal ballistics test. I'll also explain a little bit more how I came to these results. I fired one round of each sample of ammunition into a stack of saturated phone books from approximately 10 feet away. The depth of which the bullet bored into the stack of phone books is how I reached the number of penetration depth. So as you can see, the high-price sample penetrated 19 inches, while the low-price sample penetrated 14.5 inches. So you could say that the high-price sample performed better than the low-price sample in terms of penetration depth. However, there is another factor that you have to look at. The high-price sample lost nearly 50% of its mass while it was boring through the stack of phone books, while the low-price sample only lost less than 20% of its mass. There is a debate amongst the small arms shooting community about whether or not mass retention or penetration depth contributes more to a bullet's lethality. And that brings me to my data analysis and the debate between penetration depth and mass retention. So my opinion is that mass retention is the most important aspect of a bullet's lethality as it contributes to the energy transfer of a bullet to the target. However, John Nosler is the man who founded the Nosler Company and also the man who designed the bullet that was used as the high-price sample during my experiments. John Nosler believed that penetration depth was the most important aspect of a bullet's lethality, so he intentionally designed his bullets to lose a lot of mass in the front core as they were boring through a target. I have a quote on the bottom of the screen from a foreword by one of John Nosler's friends in the 6th manual of the Nosler Company for reloading. He said, "John never felt 90%, 100% weight retention was optimum. Instead, he wanted an all-around bullet, one that expanded rapidly and actually lost some weight, specifically from the front core." I disagree with this. I think mass retention actually contributes more than penetration depth, and I justify this by using the physics equation kinetic energy equals 1/2 mv squared. Clearly, from this equation, mass is an important component of kinetic energy, and the amount of kinetic energy a bullet has as it's boring through a target would result in how much the bullet transfers, how much energy the bullet transfers into the target, as opposed to some of that energy being lost to the disintegration of the bullet. This brings me to my conclusion. So the conclusion of my study after the accuracy and terminal ballistics test is that cheaper ammunition options would be a wiser choice for most deer hunters. A deer hunter would not have to sacrifice a lot in accuracy and lethality to save money when purchasing his ammunition. My conclusion is limited by the fact that the resources available to my terminal ballistics and accuracy tests were limited. I didn't have as much range time as I would have liked during the accuracy test, and that limited how many trials I could do at each distance. And the terminal ballistics test, I would have preferred to use ballistic gelatin as opposed to saturated foam books. So that brings me to the recommendations I have for future researchers. If someone wanted to take my research and build off of it, I would recommend that they test more samples of ammunition with more trials that will ensure greater accuracy of the results. And I would recommend that they find the resources to make the use of ballistic gelatin feasible in the experiment. And most importantly, I would like to see someone conduct a study that determines whether or not high mass retention correlates into high energy transfer. If this were proven true, then that would prove my hypothesis that high mass retention is more important than penetration depth. That is all.
Good. All right, Will. All right, I have the first question, row 5, which is looking at the research process. I want to know what was the most important source of information you found while conducting your research and why you think it was the most important.
The most important source of information is going back to the results of my terminal ballistics test. As you can see, the low price sample lost less than 20% of its mass. The bullets all weighed 180 grains before they were fired. And after it weighed 144.5 as opposed to 92.3. So the high price sample lost more than 50%. This proves that the low price sample, which you would expect to perform much poorer than the high price sample, actually performed better in terms of mass retention. And it proves that, in my opinion, a low price sample could be just as lethal as the high price sample, and a sportsman would be wise to choose this cheaper option when purchasing his ammunition.
Good.
Well, you have a subnote or a footnote in early on in your presentation where you talk about, when you're talking about ballistics, you chose to cover terminal ballistics, and then you mentioned that there are other ballistics that you can study.
Yes, there's interior and exterior ballistics. Interior ballistics being the motion of the projectile while it's still in the bore of the rifle when being fired. And exterior ballistics is the study of the projectile's flight.
Okay.
So exterior ballistics would contribute most to the accuracy of the rifle, or of the bullet. So I did kind of test exterior ballistics to some degree when I was testing the accuracy. Interior ballistics would be difficult for me to test with the resources that I have.
So you're beating me to the question then, which is fine, which is why choose the one that you chose?
Yes.
And what would you have to have done? Can you go back just to discuss? You said that this last one you just discussed would be very difficult for you with your resources. What would have been required for you to actually study that or test that?
So I know there's some people who measure the velocity of a bullet as it exits the muzzle of the gun, the end of the bore of the rifle. They call that muzzle velocity. That would, obviously the bullet is moving very fast. I think in this case, I'm going off the top of my head here, I think these bullets leave the muzzle at 2,700 feet per second.
Mm-hmm.
So that would be hard for me to measure. That's an average number. It differs from which ammunition you're using. I guess I would have had to have some sort of motion detector. I think they actually use Doppler radar. Some of the professional companies like Hornady and Federal Premium and Nosler, they use Doppler radar to measure the bullet's flight path just at the point where it leaves the bore of the muzzle and its flight towards the target.
Yes or no question, sorry to ask another one, I'm just so curious now. Taking all three of those factors into account, would someone have an argument for why they price it higher? In other words, if they could show in all the other factors that it's an improved product, would that be a reason enough to charge $15 extra for their product, do you think?
Yes, if they could prove that it has a higher muzzle velocity, then that would, going back to the equation that I brought up, kinetic energy equals 1/2 mv squared, v equal velocity. If they could prove that it has a higher muzzle velocity and it has a higher ballistic coefficient. Ballistic coefficient is a term used to describe a bullet's resistance to the effects of air resistance, if that makes sense.
Sure.
So if they could prove that it has a higher muzzle velocity, they could prove that it's transferring just as much energy as the low price sample that simply has a higher mass as it goes through the target.
All right, thank you.
Well, I have row 7, reflection on the process. You kind of gave us some ideas of what someone else would do to continue the research. So my question would be, if you had unlimited resources, meaning money, you could use anything, and you had unlimited time, how would you change your research and your process? What would you do differently? And could you expand it to additional animals, just like, so rabbits instead of deer or something like that?
Well, if I were to change animals, that would change the caliber that I'm studying, so I think that would bring a lot of different complications, and I'd rather focus just on one caliber. It's just a narrow topic, and I think it's easier to apply the research to. The first thing I would do is I would test more samples of ammunition. I would probably test like at least 6 more samples, 3 lower price samples, 3 higher price samples, because when I just tested 1 low price sample and 1 high price sample, that was all I could do with the resources available to me. But someone could raise the point, well, this low price sample performs just as good as this high price sample, but is that true about all low price samples and all high price samples? So the first thing I would do is I would simply test more samples, and I would also test more trials with each sample, because the more trials you do and then taking the average of those trials ensures better accuracy of the results.
Was that also an issue when you used the saturated telephone books versus?
Yes, the ballistic gelatin. This is also going off the top of my head. I think ballistic gelatin, just 1 block of it can cost around $125, and I would have needed at least 3 of them. So I didn't have enough money to purchase that much, so I had to find a different medium that would be something. If I had unlimited resources, I would definitely go with ballistic gelatin.
Awesome. Great job, Will.
Thanks, Will.